Welcome back, everyone. I'm John Furrier, host of theCUBE here in our NYSE studio. Of course, we have our Palo Alto studio connecting Silicon Valley and Wall Street. Technology is the market, and this is our AI Factory series, and our next guest is a CUBE alumni here on the NYSE Wired program. He was in Palo Alto, now he's here in New York. Honghao Deng, CEO and co-founder of Butlr.com, B-U-T-L-R.com. Was I.O., now they got a B round, they get the .com. Okay. Thanks for coming back on. Good to see you.
Thank you, John. Good to be back.
You were in Palo Alto when we just started covering the AI leaders. Now it's a full-blown series, AI Factories. Fast forward about a year and a half since we last talked. NVIDIA rises up, continues to dominate, thunder away on the innovation, supply chain, ecosystem, application native, AI native applications are coming. More and more AI is coming, so it's been quite a market. And the physical AI is now here. We've been talking about it for a year now. Agents are hot, okay, in the enterprise. I love agents. Agents work with data. We're seeing great value. But the real story in AI is the convergence of our physical and digital world. Physical AI is and will be the biggest wave we've ever seen.
100%, John. And then I think the community really looks through the corner, right? Like I think last time when we talked, the topic is really, do we have enough data to train all these large AI models? Now it's really, do we have even have enough energy, right? Indeed, like we live in the physical infrastructure, and then buildings, the roof above us, it's actually the biggest man-made product on Earth. It's not really the screens. This is the largest interface that we interact with every single day.
Yeah, and you guys have building a cool product. Last time you were on, you had the sensor. It would see, it would almost, it's almost, to me, my takeaway was like instrumenting the physical world. The way you did it. You guys had milestones since then. You got a Series B financing, keeping the team lean and mean. You got a hardware product. You give it away for free. You have a data-driven back-end, data-centric business model. Give us the update. I see some new additions to the family here on the desk. Show us the new products and tell us what's happening.
We innovate fast, right? Speed is the king now. I do have to say that like if AI is going to have a way to interact with our physical life, it's going to through like the interface around us, and I see it really not just through the screens, but through this interface, built environment. And then and it has to understand individuals' needs, right? Like it really couldn't be, like we really wish it shouldn't be that AI behind the cameras everywhere in your bedroom, in your bathroom. That's why we created Butlr.
Yeah.
We really think of ourselves as humble sense of touch to understand the warmth, the cold, the safety, and also risk in the space. So very naturally, as a thermal sensor player.
Hold on, just before you go any further, you explain, that was good that you hit that. You guys are doing a lot with the environment. Touch, sensing, video. Explain the multimodality of what's going on.
We don't use video at all.
No,
so
okay.
that's a principle. Because like we all don't want to live in a world that like we are always surveillance, no matter it's the people behind or AI behind. Even AI behind.
No one wants a camera in the bathroom. Nobody wants a cammer in the hospital.
No one wants that. No one wants that. So when we spin out from MIT, like the reason why initially we go into like healthcare use cases in like a senior living is because of my grandpa fell. And then as a nerd in the family, I put cameras around him. So
he fell at home.
At home.
And you're like, okay, got to keep an eye on my grandpa. Yep.
Yeah. It's like the.
What did he react to? What was his reaction?
He was like, he didn't say anything, but it's the family's homework for me, so like he keep it quiet and then like secretly just unplug everything.
So he didn't want it.
He obviously don't want it.
He wants to, because it was privacy for him, right? He was like, didn't want you staring at him all the day.
And then I just like, it's a quick lesson learned for me. I realized when I get to 80, I don't want my grandkids watching me over CCTV, right? Like, and we all want to live with dignity. Yeah. So that's why we build a sense of touch, right? Like, just like taking temperature, surface temperature data point. So like under the sensor, we put the sensor in the ceiling. We can easily even implement the studio now. When I put it up, it will just see like 12 of us sitting down. And then we're all like thermal blobs, just temperature. And then for obvious reason, like because we have like our raw data is like high accuracy temperature data point, it become also very natural like to use that to monitor the thermal performance in data center. Also
so you get all the imagery you need through non-video, thermal, sense, feel. Is that right?
Exactly.
So that's how hospitals would want it. So if you could detect someone falling in a hospital, say they decide to go for a stroll from their room, or it could be someone working, you would see that in the thermal image.
Correct. It's not just after effect. So that's the powerfulness of AI. It's really prediction models. So like we develop a lot of like specialized model into fall prevention, and similar ideas into like data centers. So when you retrofit a data center, it's really, and then the problem there is really like people do static control loop like based on fear, essentially. They don't want the throttling of a GPU. They don't want it's just like going to the automatic shutdown loop like when it go beyond like 95 degrees C. So that's why like when people set the temperature of the airflow, it's actually even 10 degree lower than the ASHRAE like standard. So just to keep it safe. So it's like really.
So they're not really fully optimized. Explain the data center, because this is going back with your markets. That's a hot market for you. It's a mission critical, like hospital. What actually are you providing for value? Is it the difference between highly optimized management of what's going on in the environment? Is it for detecting failures? And what's the alternative? Why are you better than what they're doing?
It's actually all of the above you just mentioned, so you were spot on. And then like, if you look at the efficiency when we build out all this infrastructure, obvious feedback we can get today is from all this like data center project being banned by the cities or being paused, because when we think about it, the efficiency is not that great, right? Like it needs actual infrastructure for water, for electricity, and then with AI taking people's job, not taking away our water and also electricity, it's just hard to swallow, right? And then it's not the most efficient way to do it. We have an inventory, human society, we have an inventory of like 80 gigawatts of existing legacy data center. And then, to be honest, the fastest way to get GPU like being turned on is actually to retrofit them. And then they
retrofit the data centers.
Exactly, the existing legacy one. Those are the inventory. And then each year we try to build another 10 gigawatts of new data centers. But like those need additional infrastructure. So the right thinking is, can we actually retrofit the existing CPU-based ones like into the ones that can take L40s, even H100? But the problematic part is that they control it based on the result. Just like I mentioned before in hospital, you only detect a fall, spot a fall. It's aftermath. It's just like the way they control the air-cooled ventilation feedback loop. It's really like you don't know the end result. You don't have the feedback loop. That's why like just crank it up to the max. And then like, to be honest, like there is like huge room to optimize to improve the efficiency, and also most importantly, understand the thermal limitation. Otherwise, they don't even know.
So it's like insurance too. You give them a predictive view of what the risks are. So if I'm retrofitting a data, just playing this out loud, okay, yeah, it looks good on paper, but there could be a blind spot relative to, say, some sort of leakage in a building with energy, air, or some flaw. Is that right?
Exactly. It's really about a predictive model, like to know the problem beforehand.
Give an example. Give an example.
Give an example is that like when the GPU is already throttling, it's already an end result. There might be lack of circulation, like it's just like the cooling is not efficient enough and get it to that end result. So you want to match the demand curve. You want to match how it got built up.
So you guys have the ability, so I'm just thinking, if I'm the data center owner or operator or whatever, I get your Butlr product and I say, okay, it's going to measure a lot of things, but I don't need custom probes and instrumentation on, say, the GPU. You say, hey, I'm going to monitor the whole area, and by the way, I use my data algorithms to saying, yeah, you care about the GPUs, and hey, it's throttling, but the air conditioning's on, the airflow, the power and cooling's working, but it could be something else. That would be like almost impossible to detect in advance.
Correct. It wasn't possible before, especially if you think about colos. Sometimes they don't even have the data points.
It's a no-brainer for them. What were some of the reactions on those data center deployments? What's been some of the feedback from the people?
Oh my gosh, they desperately need it because like there's no way they know whether they can upgrade it or not because they're already having the fear that like I don't want the GPU, the CPU right now, the legacy one to throttle, and then they don't know whether they can fit like the newer generation ones. Now we have the full data point for them to know that what's your thermal limitation, whether you can do a thermal a retrofit on the existing rack or not. What's a recommendation, and then in this way. Essentially, you can upgrade the existing rack to fit in.
You're essentially like the smart data center fabric layer of what's going on in the environment of the data center, kind of like outside of the physical plant itself, and the gear. I mean, these AI factories are basically large-scale systems. The whole data center is the computer. Everything about the buildings is going to be optimized 100% to as much as 100%. To support energy usage, efficiency, how can I get more out of the GPUs, which are, by the way, huge cost.
It's enormous cost. So like, it doesn't stop there after we recommend a new layout based on the thermal limitation by monitoring the historical performance. And then like, because of now you introduce additional data to be preventive to prevent the temperature and energy build up, then you want to have like constant monitoring to make sure it's like beforehand. You don't want to find it later on. It's already throttling. It's all about that. When you find something is already throttling, it becomes vastly, energy inefficient because you will then like crank up the ventilation, the airflow, like turn the temperature like 10-15 degrees below the standard. To just like cool down.
You're basically creating an environmental change that could be managed differently. So people just go to what they see in the training manual. Turn up the AC, get more airflow or cooling, water cooling or whatever, liquid cooling.
Yeah, it's just like...
All right, so data center is a big market for you. So you're doing well there. I can see that working for you. Other areas that you guys have momentum in? What else?
In general, it's just really about energy, right? So like it's really about, again, data center is definitely hot to trot right now. There's a lot of inbound for us. Besides that, really general speaking, if you look at energy as a whole, buildings itself actually consume 40% of the total energy of the whole mankind. And then data centers actually now is only 2%. So if you look at building, even a lot of like strategy in building physics can be applied to data center too, but it also applies to all buildings. For example, you can essentially store energy into the building mass. So pre-cool it. So when the energy are cheaper. So when the vast majority of the world or the city is sleeping, right? It's cheaper. Then you store the cooling, you store the heating energy into the building mass, into the air, and then release it later when you need it. Just by that, there's like 5% to 7% energy efficiency gain towards like all type of different buildings, including data centers. And then if you look at that, if you gain like roughly 10%, let's say like of the cooling and heating efficiency, and then the building's already consuming 40% the whole world's energy, and then you can ventilation is actually 70%, then you can gain potentially up to 10%, which is like 3%. You're creating 3% energy for the world. And data center is only 2%, and we're figuring out all the nuclear plants and also solar.
I mean, the world's like, oh my God, we have a crisis of energy, but like it's laying around in plain sight. You guys are making that happen. Explain the products now, because I get the office piece too. I think that's going to come later after the data center. Data center is a critical path. Healthcare, these are critical services. I mean, basically critical infrastructure is what you're seeing demand in, right?
Correct.
But office is kind of mainstream. I've heard stories of post-COVID, no one's coming back to work and people are turning their campuses into data centers. Why? They have all the facilities, they have all the electricity. Everything was already kind of plumbed into the system. They just turn it into data centers, put some pods in the parking lot. Next thing you know, they're running hyperscale level data centers. Exactly. Stay at home. We'll use it for a data center.
Yeah, I mean, like the data center is actually the new workplace if you think of it.
Yeah.
So we did.
If agents are continuing to do their thing, yeah. I mean, you saw the Claude bot Molt book they're calling it. I mean, that's in the data center, so in the ether. Okay, show the products. I want to get these in if you'd hold them up. That was the original one. Hold it up to the camera.
Like we showed this last time too. So this is the Generation 2 platform. So this sensor like take roughly 10 by 10 like surface temperature, and then we translate it into like location of people, and also
it's all wireless, right? No,
all wireless.
No real. No provisioning a line. No, none of that.
It is a world first and only sensor that can allow like multiple years of battery life, and then stream at 10 frames per second. So that's why we can do like mission critical fault detection and fault prevention. So
secret sauce is software.
Both software
pretty much, and the integration of tying the software to the physical thermal instrumentation. It's not so much the hardware, it's like basically, it's the key sensors, right?
That's why it's like physical AI.
Yeah, that's why, again, you love physical, you're way ahead of the curve, which I love why you came in, you can begin again. So now take us to the other ones.
This is something like we're going to announce like very, very soon. So this is like more into the use cases that are mission critical. That's like for health and safety, and also preventing risk, fire risk, and also understand detailed temperature performance of the equipment. So beyond just like, low resolution thermal temperature data point, it got like a little bit higher resolution and also higher sensitivity.
No camera.
No camera at all.
So that's the key.
That's the key.
You get the privacy, but you get all the data you need. That's what you want. And what's this bigger box here?
This one like is really, I want to like give an example of the compute.
You hold it up.
Yeah. This one.
Yeah.
So inside is it's a Jensen Nano, Jensen Orange Nano. So like people always forget how much like power consumption it is, or in reality, what does a data center's consumption look like? Like some of us still have the impression that it might just be a couple of racks down the basement or in the office. I think like the AI factory key, the word is like keyed perfectly because of it's indeed heavy industry. And then like that's why the size scale heat transfer, which we have a great like product potentially that can help there, is critical because of, if you think of it. So this thing, like this is a small like GPU server, and then a normal rack, roughly like a legacy one is like 2,000 watts. That's like roughly 50 of it. And then if you think about the heat generated by them, it's going to be a funny analogy. If you have like 2 of this, it's a slow cooker. And then if you have a legacy rack, that's an oven. And then a Blackwell is actually 50 of those regular legacy racks, the 42 U's. Like you need 50 of them to have the equivalent output of like of a Blackwell like 42U rack. And that essentially you have like 50 like ovens behind you. That's amount of.
It's a lot of compute. It's tons of power. But the smaller boxes for smaller use cases, right?
Yeah, this is like essentially like we have them. We run inference at the edge. Yeah. So essentially it can take care of like dozens of our sensor real-time understanding whether somebody fall or whether equipment go overheat, whether there's a risk of fire or even leaking in the future.
So you can run models locally, do inference, you can talk to the factory, use the internet to pull down the models you need in real time. So you're really more edge specific.
It's really about building the nervous system, right? Like I wasn't saying that like we're trying to build up the whole brain, but like Butlr always tried to be a humble nerve cell that's like connected to contribute the overall large like intelligence nervous network. So we are part of it, being the sense of touch. And the future will be, the way we see the future, it will be multimodal, just like people, right? You have eyes somewhere, and you have sense of hearing, and you have sense of touch, which is Butlr.
Well, no, it's great to have you back. I love what you're working on. I think the edge with physical AI is going to be the biggest story no one's talking about. We've been talking about for a year. It's going to get more explosive. I'm expecting GTC next month to be another barn burner of an event. I think it's going to be fantastic. We'll see more physical AI and robotics, which again is a is a tell to where the market's going. This is a practical example. I love how you're using the wireless, very clean. Now you just got to connect to the internet via Ethernet. You talk to the factory. So it's really kind of like a transceiver layer for that. It's like almost, and this is the future. I mean, I think these kinds of boxes will be kind of, you know, AI at the edge, AI factories at the edge. Just a node in the network.
Totally, and the new one is like you can wire in, and also it also can be wireless. That's the beauty of it. It's a maximum flexibility. And
why would they do wired for, like what? Just security, or?
A lot of times it's just like for example, retrofitting existing data center. People want the speed, right? Like you want to put them on collecting data and know what to do. And then when you do start to do monitoring and also having an insight, a part of your feedback loop, people want it permanently. So that's the beauty of it. You start with the wireless.
So I go for the connectivity, security, speed. So that's speed issue.
Best of the both worlds, essentially.
And wireless isn't slow either. You were saying, what's the stats on the wireless throughput that you have?
Oh, this is the we have the state of the art. We're the only one that can do 10 frames per second, maintaining more than 3 years of battery life. Nobody else can.
On wireless.
On wireless.
Yeah. Great. So that one is for people who want the wire. They want the high speed, mission critical. No big deal, wire it up, just plug an Ethernet cable into it.
If you don't want at the beginning, we see a lot of customer, you know, Fortune 10s, they start with wireless and then they wire in, become part of the system.
Well, we'll keep in track. I'm sure you're going to be very relevant as the edge continues to get smarter, more intelligent. This is a great example. Again, love the no camera, humble nature. I think that's really a great decency, but it's also like, nobody wants to be surveilled in these mission critical, but they want the data.
Correct.
You got it. Thanks for coming on. Great to see you again. Physical AI is coming. This is theCUBE and the NYSE Wired program, CUBE Original, connecting Silicon Valley and Wall Street. I'm John Furrier, host of theCUBE. Thanks for watching.